My other condition is that the expected counts, and we call these cell counts, are all greater than 5, or if I have an expected count that's between 1 and 5, that it is that I don't have more than 20% of my expected counts between 1 and 5. Okay. So, how do I get my expected counts? Well, if you're lucky, you get them on the calculator, but you're not there yet, so my expected counts are the row total times the column total divided by n. Okay. So I'm going to be going back and forth a lot on this one. So here's going to be my two-way table for the expected counts. So for that, maybe I should make that number a little further over. I mean that label a little further over. Yes. No opinion. For the juniors, let me go back up to my table. The juniors that say yes, the row total is 16, the column total is 7. Thanks. We were doing probability and algebra 4, and so I had given him some coins to do it with. And he gave them back. All right. What were those numbers again? 16 and 7. So that is 16 times 7 divided by, what was our total? 28? Give me a number, please. Okay. So far we've got one less than 5. For the seniors saying yes, it's 16 times 21 divided by 28. Okay. For the juniors saying no, it is 7 times 7. Okay. We're not going to meet conditions. We didn't last period either. Okay. So we probably shouldn't be using the chi-square distribution, but we're going to run it through anyway. All right. So for the seniors saying no, it's 7 times 21 divided by 28. .25. Okay, I'll call it 5.3. I think these no opinions are going to kill us too. That's 5 times 7 divided by 28. And 5 times 21. So our expected counts are low. We had too small of a sample size. Sorry, we haven't met conditions, but let's move on. We have checked them, and we haven't met conditions, but we'll keep going. Yeah. Well, let me just show you how to do the procedure. Yeah. Okay. All right. So now that I have my expected counts, I go down to get my chi-square statistic, which is going to be observed minus expected squared divided by expected. Sum those up. So my observed was 2 minus 4 squared divided by 4 plus, what is that, 14? Minus 12 squared divided by 12 plus 4 minus 1.8 squared divided by 1.8 plus 3 minus 5.3 squared divided by 5.3 plus 1 minus 1.3 squared divided by 1.3 plus 4 minus 3.8 squared divided by 3.8. And I have no problem waiting for this calculation to come out of a few calculators, see if we can get the chi-square calculated correctly. Oh, yeah, just put it in a list. I'll cheat on mine and do it in the calculator. Well, cheaters never prosper. I got 5.25, but that's a rounding error. About 5 point something. Okay. I need degrees of freedom to go do a chi-square. My degrees of freedom are the number of rows in my two-way table minus 1 times the number of columns in my two-way table minus 1. Can you tell me how many rows we have? There are 3 actual rows in my two-way table. I don't count the totals. And 2 columns. So that's 3 minus 1 times 2 minus 1, better known as 2 degrees of freedom. My p-value will end up getting, using the chi-square CDF, will go from 5 point whatever. I got 5.3, you got 5.5? 5, all right, so we're just going to call it 5. That's good enough for me. Comma, positive infinity, comma 2. And you give me a p-value when you're ready. .082. All right. If we had met conditions, now I would say since my p-value is greater than 0.05, we fail to reject. Our null hypothesis, we do not have evidence that I'm not going to put it that way, that the juniors and seniors answers to these questions are in any different proportion. Why don't we have evidence? Because, Danielle, remember we didn't meet conditions? Yeah. We didn't meet them in a big way with those cell counts, and that is what killed us. Yeah. No, they didn't either. Yeah. They got a much higher p-value. Lowering